Exercise 1.1 of Class 12 NCERT book. Questions on reflexive, symmetric, transitive, and equivalence relations.
Show that the relation R in the set A of all books in a library of a college given by R is equal to x comma y if x and y have same number of pages. This relation show that it is an equivalence relation. This time the set given to us is set of all books in a college. In a college library there are so many books. That is a set given to us. And a relation is defined from this set to the same set, A to A, A to A. These books have various number of pages. Book may be having 100 pages, book may be having 150 pages, 210 pages, 300 pages, and many more books having different number of pages. Now, which book will be related to which one? Condition is given here. Book X will be related to book Y if X and Y, both of those books have same number of pages. So we can see this book with page 100 will be related to another book having 100 pages. Another book here which is having 180 pages is related to a book having 180 pages. Again, a book having 210 pages can be related to the same because this element follow this condition. A book having 210 pages and another book having 210 pages have same number of pages. So a book can be related to the same also. Now, is this relation a reflexive relation? Here we already noticed every book X has same number of pages as itself. Since it is so for all the books, the elements of the form X comma X will belong to R. That is, every book X is related to the same. Every book X is related to the same. So, this relation can be called a reflexive relation. Now, is it symmetric relation? Let's take an element X comma Y that belongs to this relation. One X comma Y, one pair of book X and book Y. If this pair is there in the relation, that implies that X and Y must be having same number of pages. That is why they are related. That is why this pair is taken to be in the relation. If such a pair is there, these two elements, these two books will have same number of pages. That can be written as Y and X have same number of pages. These both statements mean the same, which implies the pair Y comma X also will belong to R. This is what we needed to have to call it a symmetric relation. Whenever a pair A comma B is there in the relation, B comma A also should be found in the relation. Yes, it's happening. Whenever a pair of books X and Y belong to the relation, the pair Y and X also will belong to the relation. So, this relation is symmetric relation. Is a transitive relation. We'll go by taking two pairs which are there in the relation X comma Y and Y comma Z. Let there be these two pairs in the relation, which means X comma Y belong to R means X and Y have same number of pages. YZ pair belong to R means Y and Z have same number of pages. Look what these two statements say. X and Y have same number of pages and Y and Z have same number of pages. Which means X and Z have same number of pages. That is, X comma Z pair also will be there in the relation. So even this conditional statement is satisfied here. The transitivity definition says, whenever there are two pairs of this kind having the element B common, then the pair A comma C should also be there in the relation. Yes, it's happening. It's a conditional statement. Whenever these two pairs are there in the relation, the pair X comma Z also found in the relation. It is logically proved. Hence, this relation is a transitive relation. It is found that this relation, the given relation, is reflexive, symmetric, and transitive. A relation R in a set A which is reflexive, symmetric, and transitive is called an equivalence relation. So, this given relation is an equivalence relation. Something more about it. Look, in this set is now the union of many disjoint subsets like this. The subsets are set of all books having 100 pages, set of all books having 130 pages, set of all books having 230 pages, another set having 300 pages, and there can be few more subsets. Basically, each subset has books of same number of pages. These subsets are disjoint also because no book will belong to two of them. No common element. That is why these subsets are disjoint subsets. And if you take total union of all these subsets, total union is the complete domain. One thing more. In this relation, elements of each of these subsets are related only to the elements of same subset. Obviously, this book having 100 pages cannot be related to a book in another subset having some other number of pages. This book having 100 pages will be related to some book of the same subset. Same with this subset also. Each element of this subset will be related to the elements of the same subset, not to any book outside the subset. These subsets are called equivalence classes. Equivalence classes.